Alright, this video is on identifying electrolytes. Based on your reading yesterday, you should know what an electrolyte is, what a strong electrolyte is, so on and so forth. We're going to give some examples of electrolytes in this video, and you're going to need to identify the components of that electrolyte. So you'll have access to these notes, obviously, and you'll have these three tables. You'll have this table right here, this table right here, and this table right here. And I'm going to go over these three tables in detail as far as what you should be paying attention to. Okay, so let's go and take a look at the first table. This is all ions you can get straight off the periodic table. There are a couple anions they left off. Let's see, we have the N3 minus, which is the nitride, and then we also have the P3 minus, which is phosphide. So let's make sure that we write those down since they are not in your table for tomorrow. And then the one that's kind of odd is the silver ion, which normally you would think, well, silver is a transition metal. We don't know exactly what the charge is. Well, as it turns out, silver is one of those transition metals that only likes to form one charge, and that charge is silver plus 1. Okay, so make sure you jot those down. Looking at our next table. All right, the older names that we have over here, I am not worried about in the least. Okay, I'm not going to require you to know anything about that. Just know the systematic name. Okay, which includes the metal's name and the charge written as Roman numerals. Okay, so if I have the iron 3 ion, I would write it out as iron and then a Roman numeral 3, right? And then so on and so forth as we go down. These are all pretty straightforward. Iron 2, copper 2, copper 1, cobalt 3, cobalt 2, tin 4, tin 2, lead 4, lead 2, mercury 2 plus, and then there's another mercury 2 plus, but it's a diatomic, and we actually consider that to be a polyatomic. And that would be the mercury 1 ion. And as it turns out, okay, the mercury 1 ions always occur as two atoms together. So technically, this shouldn't be on this page. It should be on the next page, which has the polyatomics, because this is actually made, as you can see with the little subscript right here, it is a polyatomic ion. Okay, so the mercury 1 ion is a polyatomic that's a 2 plus. Okay, so let's make sure we realize that. And then, of course, there's just the regular mercury, which does not exist as the mercury 2. It just exists as one atom of mercury with a positive 2 charge. Okay? So, looking at the last one, these should be familiar to a point. We've seen them before. So we have polyatomic ions, as you can tell, other than the mercury 2 plus ion, and the ammonium ion. These are the only polyatomic cations. Okay, all the other ones, as you look, they're all negatively charged. Okay, so ones that I would say you should really know. Okay, you should really know nitrate. Okay, you should really know sulfate. And now this is not, you really need to know this for the worksheet tomorrow. You're going to have access to this. But I'm talking for the test. These are the ones that you really should know. You should really know the hydroxide ion. You should really know the cyanide ion, the phosphate ion, okay? The carbonate ion, the hydrogen carbonate ion, which also is known as the bicarbonate, and usually that's the name that's used, okay? The acetate ion, the permanganate ion, okay? The peroxide ion, and probably the, let's see, 1, 2, 3, 4, I don't want to overload you guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Yeah, we'll go ahead and leave it at that. Those are the 10 that you really need, to know. Okay. But you'll have access to this table for your worksheets, but you will not have access to your table for your test. So a grand total of 12 polyatomic ions you need to know. There's 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, since they're the same one, and 10 anions, and of course these 2 cations. Make sure you know those. So let's go ahead and do a couple examples. All right, so let's start off with something easy. How about potassium chloride? All right, nice and easy. And I'm just going to use the tables, even though we probably do this one in our sleep. I'm still going to use the tables so we can figure it out. So obviously, when it comes to electrolytes, cations are listed first. So I'm going to look at the common ions for polyatomic. Or for monatomic. There's potassium right there. Okay, and that's a K plus. Right, so that's K plus. And then my chloride is Cl minus. So Cl minus. And then I look here, that means I have one positive charge here, I have one negative charge there. That is in equal ratio, so when I write out potassium, when I write out potassium chloride, it'll be just KCl. Alright? Let's try a couple other ones. So we have lithium sulfide. So lithium is right here, so that's Li1, right? So lithium plus. And then sulfide, if I look here, sulfur is, the reason why I went to this table was because sulfide, the IDE, remember those IDE are very common to monoatomic ions, meaning they are not polyatomic, meaning they only make, the polyatomics have more than one atom, monoatomics only have one. So I'm looking here, I see ide, because if you look, ide, and ide, right? Here's sulfide right there, which is an S2 minus. So that is S2 minus. So if I was to look at the charges here, I have one positive and I have 2 negatives. Well, if I put those two things together, I would not get a neutral compound. I would need 2 lithiums, right? I need 2 lithium ions to form the neutral compound, and that neutral compound being, okay, Li2S, and that's lithium sulfide. All right. On the worksheet, you're going to have to do both of these. You're going to have to identify what the ion is, the cation, the anion, and what the final formula is. All right, so let's go and take a look at another one. Here we have aluminum acetate. So first thing, aluminum is a metal. So I'm going to look at the monoatomics right here. Aluminum is a +3 ion. Okay, right down here. All right, so that is Al 3+. And the acetate ion, which is not ending in ide, so I'm going to look at the polyatomics. And acetate is right here, C2H3O2, and it has a -1 charge. Okay, so we have C2H3O2, and it has a -1 charge. Now, it's important to understand that acetate may be written a couple different ways. Okay, but if every time you see it, it'll be like this, how I have it with this one. Okay, so I look at my charges. I have 1, 2, 3. I have 1 over here. Obviously, if I put those together in a 1-to-1 ratio, it would not work out. So I need 3 total acetates to balance it out. So when I write this equation out, okay, it's going to be obviously Al, and I only have one of them, but I need to go C2H3O2. Now, if I put a 3 right here, it's going to look like C2H3O23. So because it's a polyatomic, I need to put it in parentheses. Okay? So let's go ahead and take a look at a couple more. What I'd like you to do is write out the ions and the formula, the molecular formula, for both of these compounds, calcium nitride and calcium nitrate. So go ahead and pause your video and write these out, and let's see the difference. Okay, I want to talk about this one real quick. So calcium nitride, calcium has a 2 plus charge, nitride has a 3 minus charge. If you count out your charges, I need to have 6 positive charges and 6 negative charges with the calcium nitride respectively. The reason why I do that is because 6 is the least common multiple. Okay, and of course the other way you can do would be to take that number and make this the subscript for calcium and make this the subscript for nitride. In either case, this is your answer. And then calcium nitrate, calcium has a 2 plus charge, nitrate is a polyatomic with a -1 charge. It's polyatomic and I have more than one of them to make everything balanced out, so I need my parentheses around the nitrate with a subscript of 2. Okay? Now, tomorrow when you guys do your worksheet, and I'll show you that real quick, or better yet, I'll just do this. Okay, you're going to have something like this. You're going to have a column for name, a column for cation, a column for anion, a column for formula. So if I was to fill this out for the, let's say the calcium nitrate, okay, I would have to write Ca2 plus, and since I only have one of them, I'm only going to leave one of them. But I needed 2 nitrates, so I'm going to include the coefficient, okay? And then I draw my formula. Okay? You'll have like 25 of these tomorrow. Okay? They should be able to get done by the end of the period.